that as well.
Math raises none.
I was doing the answer key for the test that BC took yesterday, right? Okay.
The bad.
I was like partial fractions, and it was this, and I got the partial fractions, and I did all this, and I got all the way down to the end, and I got this for my answer. Okay, guys, look.
Yeah.
I got ln of the absolute value of negative 1/5 minus the ln of the absolute value of negative 1. Okay? And I was like, oh, I know that that's the absolute value of negative 1 is 1 and ln of 1 is 0. And I got that. I'm like, sweet, I'm chilling. And then I started looking at the answers. And I was like, clearly I'm not chilling. Because, look, ln absolute value negative 1/5. This literally just happened to me today.
I hated that problem.
Okay?
I didn't do it.
Yeah, you guys probably didn't get it right?
Yeah, probably didn't.
So we got down to right here. And my choices were like some weird arctan thing, something else. My choices were, it gave me ln 5, and it gave me negative ln 5.
It's negative ln 5.
Okay?
Abby knows mine, I think.
And this is what I came down to for my choice. And I was like, what the heck? Like, I had to sit there for a minute. I don't even think that that is one of those. Right?
Lydia.
But
I saw Connor, and I don't know what you see.
you guys, it actually totally, this is one of those. And today's session is inspired by questions like that, where, how do I know which one this is? For my AB students, we took a test the other day. You guys did the whole thing, and the answer was 3 ln 3. Right?
I don't remember that.
Yeah, that was the Unit 3 test, I think. It was 3 ln 3. And your choices were like ln 9, ln 27. And I swear nobody got this right. Okay? Did you? Okay. Here's what's on my head. Because, guys, the answer, we're looking for 3 ln 3, but it didn't give that to us as a choice. It said it's either ln 9 or ln 27.
Oh, they're right there.
All right. It is ln 27. This is why we have to review exponentials and logs, okay? Because this crap comes up all the time. There's a problem that was like negative ln cosine. And instead of writing negative ln cosine, it's the same thing as positive ln of secant. And it's like, what? Right? So there's all these ln rules that you have to know, or you can't do the end of the problem. You can do the calculus, okay? So I printed this out. You guys know what OpenStax is?
Oh, yeah.
Free textbooks, basically. So I was trying to find a good ENLN review, so I stole from OpenStax, but it's not stealing because it's free.
They make audiobooks of the OpenStax textbooks.
Yeah, it's insane. OpenStax is amazing. Okay? So it talks about the different things we're going to learn. Look, we're not doing hyperbolic, but everything else we're going to talk about today, I'm going to roll through it. You don't have to even read all this stuff. I just printed it all out. All right? Okay. This kind of talks about where these equations come from. This is a very simple growth equation. We don't really use that one, but it's similar, you guys, to the questions we were using in BC, the exponent properties. Yeah. You know, the question that we've been using is P e to the kt. It's very similar to that when you have continuous. All right? So, blah, blah, blah. Okay. It talks about what's the difference between x squared and 2 to the x. Hopefully you guys know that. Right? X squared is a quadratic. It's also a polynomial. 2 to the x is an exponential. Which one grows faster? 2 to the x grows much faster. Okay? So maybe like not at the beginning, because if you look at negative 3 squared, that's 9, that's 1/8. This is like growing, you know, that's 4, that's 1/4. As I go through here, this starts getting bigger and bigger and bigger, and then eventually this one grows way faster than that one. Okay? So we talk about, like, as things approach infinity, which one's going to become larger first. Exponentials will always be larger than, like, polynomials, all right? We were talking about that when we did, like, limits to infinity, like what grows faster. Even if it's like x to the 10th and 2 to the x. 2 to the x is still going to grow faster. Okay, so that grows faster. Now, if you ever have to draw a graph, like make yourself some notes right here, of an exponential. Okay? So I want you guys to know how to graph exponentials. you want to do 2 points. Always like 2 points, right? What are the 2 points I'm going to use for an exponential to graph it? 2 to the 0 is 1, and 2 to the 1 is 2. So I go 0, 1, 1, 2, and then that's my graph.
Oh, this should just look kind of like a modified graph of E, right?
Exactly, because E is an exponential. And one of the things that I need you to know is very quickly to know what the graph of e to the x and ln x look like. Okay, so we're going to go over that in here. E to the x graphs the same way as 2 to the x, it graphs the same way as 5 to the x. You use these 2 points. Anything to the 0 is 1, anything to the 1 is itself. Okay, so that's how I graph that as opposed to like a parabola that's x squared. What you guys want to remember about this is there's an asymptote with exponentials right along here. Okay? So we can talk about limits to infinity. As this goes to infinity, that's going to infinity, and it approaches it a lot faster than like x squared, for example. As I approach negative infinity, what is it going to? 0. Right, so if you ever have a question that says, what's the limit as x goes to negative infinity of e to the x, it's going to be 0. Okay? And you can get that by looking at the graph. Does that make sense? Okay, let's see what's important here. Let's go ahead and like, it's talking about, we're used to using this with, like, fractions. 9 to the 3 over 2, right? You guys, you should know how to do that. We have to do this a lot of times in calculus, too. Like, 9 to the 3 over 2 means 9 to the third, and then take the square root of it, right? Or the square root of 9, which is 3, to the third, which is 27, okay?
Very good.
But we can, like, you can do things like 2 to the square root 2. It's just not something you can calculate. You have to use a calculator to do that. That's all I'm saying. All right?
How does the calculator do it?
I can
Not
tell
too
you.
bad.
It's just, you take the
Yeah,
square root.
but
It's the job.
Decimal, you just take 2 from the top.
Find some rational numbers approaching square root and the values of rational numbers as well.
No, but you should figure it out.
I don't know how they calculate that. I'll be honest with you, Ben. I do not know. You should research it. Okay?
They always make me do it.
I know. Okay, I'm not going to go over these like checkpoint ones. We don't really need to do that. All right? But you do need to know the graph of exponential functions, okay?
I know what it is, Mitchell.
What?
You have to look at the more complex version of how powers work. You can't just use the 3 times 3.
Like 3 times 3 times 3, you gotta go like,
There's a more complicated function you can use. and
because it's
not
like
exactly-
ln, or maybe it could come down in front or something like that.
Yeah, something like that.
We can research it. Okay.
All I
So
can-
anyways, when we're graphing exponentials, you guys, any of these, it's going to be the exact same thing. I only need you to do 2 points. I know I'm like flying through this stuff because it doesn't matter. I just didn't want to like cut and paste little individual things. Okay? So look, if I'm graphing 2 to the x, what points do I use? 0, 1, and 1, 2. 0, 1, and 1, 2. Right? If I'm graphing 4 to the x, I use 0, 1, and 1, 4. But they're all going through that point, and they all have an asymptote. Now think about a fraction, okay? Now first of all, let me ask you guys this question. 1/4 to the x is the same as 4 to the what? 4 to the what?
Negative.
Yeah, exactly. It's the same thing as 4 to the negative x. So I would actually graph those both the same way. You could use 1/4 of that. Yeah, now the one way you could say it is, look, it's just the translated version of that, so it goes that way, right? You could do that. Or you could say, okay, 1/4 to the x. Same thing, if I'm going to do 2 points, you guys, 0, 1, 1, the next one would be 1, 1/4. So it goes 0, 1, 1, 1/4. And so it like comes down here and then kind of draws it down like that. Does that make sense? So 1/4 to the x and 4 to the negative x are the same thing. But no matter what I'm graphing on exponentials, I'm going to graph 0 and 1. Okay?
And 1/4 to the x isn't an inverse of 4 to the x, right?
No, an inverse of 4 to the x would be, solving that would be log base 4 of x. That's the inverse of 4 to the x is logarithms, which is what we're going to get to, actually. Yeah, exponents and logarithms are inverses of each other, so we're going to talk about that. Okay? Guys, can you look over those and tell me if anything looks super confusing or if you understand all that?
I mean, you've been making us do 1 to move C around.
Yeah, we've been doing that one forever, right? In
we've done
BC, we've been
2.
doing that because like e to the x plus a constant, and then we can separate it out and make a new constant. Like we've been doing that.
Used to math.
Yeah.
2 is common.
Yeah. So these are my exponent rules. You guys got to remember these, okay? One thing you'll notice.
Can't come here to sleep, dog.
Same base, same base. Well, that just raises to a power, so that's fine. Okay? But same base. If I have the same base and I'm multiplying, I add the exponents. Right? But the b doesn't change. It's just b stays the same. If I got the same base and if I'm dividing, I subtract the exponents. And if I have a base and I'm raising it to a power, I multiply the exponents. And so I was doing this in my Math 3 class the other day, and then someone was like, hey, do you ever divide the exponents? And I was like, psh, no. And then I was like, actually, yes. When do you divide exponents? I mean, not like really, but kind of.
I mean, if you're dinking around
Like-
fractions, sometimes you...
Sure, how about like that?
Oh, like when it's a square.
Because roots divide, right? So yeah, they were like, okay, if you multiply, you add. If you divide, you subtract. If you raise to a power, you multiply. Do you ever divide? And I was like, no. And then I'm like, oh, actually you do when you root something. You divide.
What if there's something to the power?
To the power, yeah, you can't make it go a to the x to the y just by doing that. Like, that would be a different thing. Okay?
But it's not, like, number 3 is not bad. That's multiple.
Right, because it's x times y. So, for example, a to the 2 to the 3rd is a to the 6th, not a to the 8th. You're not doing 2 to the 3rd, you're just doing 2 times.
Is Ln's the inverse of E, right?
ln is the inverse of e, that's right.
And inverse is thought was 1 over...
So, our log properties that I'm going to teach you guys come directly from the exponent properties, okay? So you should all know these, that's not a big deal. This, it's just saying if two things are raised to an exponent, a and b are both raised to that. Same thing when you're dividing, that's not that, nothing crazy there, okay? But of course, then we could just get nuts. What do you guys think? Can you guys do these? Let's do it. Let's see how good you are. We just go crazy. It's like, oh, come on, like a to the x times b to the x. It's so easy, and then it gives you that. Right?
This is not fair. Hold on.
It goes from like 0 to 100.
Wait.
Kind of just
I don't like that.
subtract, right? Oh, no, you just go like this. 2x
What's
to the
3 times
2/3
Minus 9.
4x to the negative 1/3
Minus 3. You have to do
3 halves.
That's why I was like, yeah. And then I was like, hold on, what?
I took a charge and then
Actually, I saw
How long is
that.
one
I
long?
did see it, so I was like,
yeah, I go to the charger and it like doesn't hurt no more. Every Thursday. Okay, fine. So I went back in. I saw my orthodontist. His son was.
Oh, yeah.
Yeah.
Okay, I finished.
He's like that. He's like this split.
It's gonna be right there.
Was it number 5 that was getting off? Dude, I want to take that guy out. I think so. I've done it yet. Let's look. Okay, ready?
Yeah.
You guys think you got it?
I stopped doing it.
Why?
2/3.
I don't think you do.
I don't remember.
I was wrong. You were right. Wait, that actually makes a lot of sense.
Okay.
Wait.
That is not the path I took. I didn't think it was straight.
Did you bring the X up?
So the first thing I have to do is I got to do both of those to cube. So 2 cubed is 8. X to the 2/3 cubed, if I multiply that, is just x squared.
Is it 2x on the bottom?
Wait, why is it?
No.
Oh, she didn't.
And then 4 squared is 16, and x to the negative 1/3 squared is x to the negative 2/3. And then I said, if I'm dividing, I subtract my exponents, but I'm subtracting a negative. So 2 minus negative 2/3 is 2 plus 2/3, which is 8/3. Now, I want to show you guys a couple other things. This is how Emily did this. Watch this.
Okay, Emily.
This actually might show up on like an ACT or something. They don't usually simplify quite this much on the AP test, but look. The cube root of x to the 8th cannot be simplified down at all.
Yeah.
Because, okay, when we do a square root, we look for pairs. When we do a cube root, we look for cubes, right? So look, if I have 8, 4, 5, 6, 7, 8. Look, I got this little gang right here, right?
You can do.
Did I tell you guys the analogy about they're in jail and they're trying to escape from jail?
Yeah.
But you can only escape from jail if you have somebody that looks like you. That's what's squared. If you have a cube, you have to have 3 people that look the same,
Why do you
right?
need 3 people that look the same?
Because x to the 3rd cube root is x, so that's how you get
No,
1.
I mean for your jail analogy.
Because you gotta get 2 people on your gang. I don't know.
No,
man.
because having one other person that looks like you.
One
makes sense.
distracts the guards with their maximum security, so there's another guard hiding, so he takes down the second person, so only one gets
So
out.
this is just if it's two, it just means higher security.
Maximum security, baby.
Make sure
So,
you got it.
1 gets out from there,
Sacrifices.
and then I have 3, right? So, 1 gets out from there,
Oh, because you cancel out the
and then
So it's just.
there's 2 left.
The whole thing is just. Wait, so now it's x. This is square.
Which,
Can you have
if you
x
think about it,
8 divided by
Oh my god.
if you think about it, is x squared times x to the 2/3,
No.
which is
No.
I mean, you know.
You suck.
Wait.
Then why is it 2x?
Yeah.
Um,
Because you're multiplying it. No, it makes sense.
No, wait.
Okay, from here,
Why do we need to go?
Oh, you multiply x, so it's x squared.
It just depends on whether it's a multiple choice. This is
good? Okay, here's our next one. Ready? X to the 3rd squared is x to the 6th. Y to the negative 1 squared is y to the negative 2.
Over x
That's
to the
x to the negative 2, y to the negative
And now we
4.
subtract x, but that's just adding them, so it's x to the 8 and y
I was thinking to go
to the 2.
You're right.
Okay. Wait, I understand this part now. Okay.
Okay?
Just add to it makes more sense.
Is that it?
Oh, yeah, you got subtract makes sense.
I mean,
That one's a lot nicer.
Oh, since they're multiplied by each other, we don't have to really FOIL that.
exactly. You only have to FOIL if there's like a plus or something. Yeah, exactly. That's a really good point. You guys look.
I was just saying, these are already covered.
If it was like that, whew, that's a whole different ballgame, right? Now all of a sudden I'm foiling that. But if there's not a plus in there, I just do each one to the second, okay?
I love multiplication.
I know, Sam. This one's not that bad. 6 and 12 reduce, right?
Slow your what? Oh, down here though.
Yeah, go ahead.
Wait, why did you ask for that? Because I want to see if I can do it right.
Hey. X, ln, e should be equal to e to the x.
That's negative.
And so that's y minus negative 3. So
Nope.
then you bring the y down. So it's
Oh yeah, x over 2y to the 3rd. You said over and negative, but yeah, x over 2y to the 3rd. Or x times y to the negative 3, you're right.
I don't know. Oh yeah.
Okay?
X times 2y. 2y to the 3rd, right?
2y to the 3rd's on the bottom, yep.
Wait, is it xy to the negative 3? Why is it
So there's one, you can write it as 1/2 xy to the negative 3, or
Oh
yeah.
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 Because I can't. That's what we did at the.
it's the same thing.
Howard?
Oh wait.
It's like this over 1/3 x to the 3rd is the same as x to the 3rd over 3 when we do integrals, right? Same thing.
I have to
It's all
have
good.
great thoughts.
No, you're fine, you're fine. Okay.
Is that
Okay, that's the same thing. So I got it. We're okay.
Guys,
The answer's right.
today in my Math 3 class, Sam does. Did I have it today? Or do I have it tomorrow? Oh. So we didn't talk about E yet. I'm talking about this with you tomorrow.
Sam, are you doing BC Calc?
Okay,
For today.
for today, yes. He's signing up for it for next year. Okay. Now,
We'll just know everything. Wait, are you not an AB or BC?
I'm want to do BC.
he's not an anything right now. He's just hanging out.
Oh, yeah.
To enrich his
Why
soul.
would you willingly do that?
Okay, guys, look. If you want to
If I
know,
didn't have to, I would not be here.
if you want to know where the number E came from,
I watched a video on it because I'm a
Dallin can explain it to you. She's a nerd. Okay, look. Okay,
I'm not gonna let Dylan explain anything.
okay. I start with a certain amount, and then the rate plus that amount, it grows. And then I start with a certain amount, and then the rate plus that amount grows, and it like gives me that. And then it grows, and it gives me that, and it grows, and gives me that. And it keeps growing. And as it keeps growing, that keeps getting bigger, and that keeps getting bigger. Okay?
But like, that's really complicated.
It's very complicated. What's up, Maddie?
Any sense.
Imagine not knowing e to the power of 0.
You don't?
No, that was Raina!
Raina! That's why we're here. Okay. So guys, look.
Dude, literally, why does everybody have stuff right after school? You're just murdering all of us.
I know. I love you guys.
No, literally, like half of us came from stuff.
You're amazing. So guys, if I take this, which is basically what was happening, that was getting bigger every time I was compounding it, and that was getting bigger every time I was compounding it. And it's like compounded interest, like you can say, okay, I'm going to compound it every day. No, I'm going to compound it every hour. Now I'm going to compound it every minute and every second and every microsecond. And eventually, as you go to infinity, you get a specific value.
Wait.
So I actually did this with my class today. And we put this in our table, and I started plugging in numbers. And I went up to like 1 million. And when I plug in 1 million, so it's like 1 plus 1 over a million to the 1 million, what does it look like it's giving me right here? And it is, okay?
What's the number 2 could have the Taylor series expansion?
Taylor series puts it into a polynomial that's multiplied out instead of just something fast.
Which one's better?
That's what you do.
Yeah, probably Taylor series because you can get better numbers a lot quicker than that.
Guys, you want to know why it's an E instead of some other letter? Euler, which is pronounced Euler, but there we go.
Yeah.
It's Euler.
Okay,
We found that out.
now, I need you to be able to know what the graph is of e to the x. Right off the bat, no worries. You guys should be able to graph it. In fact, for BC and for AB, it's later on, but Chapter 8 is area and volume, and if you can't draw a good picture, you're not going to be able to do area and volume. Okay?
Wait, so if you're not good at art, you're screwed?
Not art, like knowing what graphs look like. I'm not good at art, but okay?
Nobody with good handwriting.
They're fine.
That's why we're here.
They're gonna be fine. All right.
You guys are gonna do great.
What numbers did I tell you guys every time?
Yeah, they get the whole year to do this.
Okay. What numbers did I tell you every time that we're gonna plug in to make our graph? Every time. 0, 1. E to the 0 is 1, and e to the 1 is e. Right? That's wrong.
That is 1 over.
So look,
That's the right side of
here it is.
The other one.
E to the 0 is 1. E to the 1 is e. And you guys,
starting to draw.
Did I do the ln?
Oh, this
No,
is
you
our
didn't do the
test,
one.
wasn't
Yeah,
it?
you did
You did
1 over.
both.
okay?
That's E.
It's lose-lose.
And the reason that I want you guys to know this graph, does it look like all the rest of our exponentials?
I think
Yes.
that's LN.
Right?
think it is.
All the exponentials look the same.
Yeah, that's right.
Is
ln goes like really down. It's the inverse of g. It goes from the negative infinity up to.
I want you guys to do that.
So, wait, what are we doing? Wasn't it?
I'm just skipping. I'm on
Pages, like-
page whatever. I don't know. I'm not never.
We're not even using half this paper. You are just a tree swatter.
But then, when he gets it smaller, you're like, there's not enough space. There's not enough space.
Space for what, dude? We've had 2 questions.
Okay.
Kill the tree.
Those three, you guys should be able to look at and know, or at least if you're given that on an AP test, you should be able to graph E and figure those out. So tell me what those three limits are real quick. The limit as x approaches infinity of e to the x.
Infinity.
The limit as x goes to negative infinity of e to the x.
0.
And as x goes to positive infinity of e to the negative x.
I don't know that one.
Isn't that just negative infinity?
Negative infinity, that's 0 too.
Yeah,
But the last two limits are the same.
they are the same.
Whoa.
But you'll see them in both forms.
Does somebody want this orange?
Me?
No, fine.
I'll take it.
Okay, alright. So look guys,
Sadness.
if I know what the graph goes, as x goes to infinity, this goes to infinity.
Yeah, I had wrestling and then dance.
Okay?
Action.
As this goes to negative infinity, it's getting closer to 0, right? And this is the one we actually see the most often. I've seen that very recently in BC, the problems with the carrying capacity.
Oh yeah,
Right?
it goes to the net.
Remember, because it's e to the negative kmt.
Yeah.
And if it goes to infinity, what's the e to the negative infinity? 0. So we use that idea a ton. And it comes directly off this graph.
Have you graded our tests?
Oof, I gotta do it tonight. I'm not looking forward to it.
Yes. Oh.
And I'm going to see Beauty and the Beast. So am I going to be grading while I'm watching Beauty and the Beast? I don't know.
Literally, just don't even grade mine and give me a 0.
That's basically what's going to happen. Yes, I'm going tonight. Okay. Oh my gosh.
Wait, go back on this.
So, my wonderful children, there was a question like this. Again, BC, I'm just referencing that because they took a test. On your test that you all practically freaking tanked.
Yeah, because I didn't know
So you
what
mean
happened.
18? Or is it?
Y equals, no, it's like number 3 on.
Wait, I got that one right.
I could guess because it was 69.
it was C.
Yeah, go for 69. You always go for 69.
We use
and
C
then
here,
you're right.
Mitchell, not P.
I know, but I'm just using whatever. That doesn't really matter. Okay, so guys, look.
Okay, that was a
This is not a calculus question. Okay, this is an algebra question.
I probably could have done this last year.
500 is invested in an account at an annual rate of 5.5. That's 0.055 times time. Right? Okay? Okay, guys. Compounded continuously is like I was just saying. Okay, I don't know. I think my bank probably compounds my interest monthly because at the end of the month they send me a little statement and they're like, hey, you got a penny in interest. And I'm like, hey, thank you. Right? But if I said, okay, I don't want it to compound monthly, I want it to compound daily at the end of every day, guys, at the end of every day, it would calculate. And then I'm like, that's not good enough for me. I want you to contact it hourly. Then at the end of every hour, they would do it. At the end of every minute, every second. Continuously means it's constantly going. Okay? So things that go continuously are like population growth, bacteria in a cell, things that are always growing, right? Okay? So all you have to do is blah, 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 find the formula for A, find the amount of money after 10 and 20.
Continuous compounding is such an abstract idea.
It really is.
'Cause you'd
But
think
that's
it
where
just
E
go to
comes from.
infinity, like, instantly.
So you would just plug in 10 or you would just plug in 20 and you could figure out what amount you're going to get. Okay? You guys understand that?
I forgot all of these equations.
You know.
How do you remember all of the equations?
Wake up, wake up, wake
Because
up.
I've been doing this my whole life.
If you're
All
not
right.
paying attention, don't come. This isn't required.
No, I made him come. He didn't get a choice.
Oh, well then that's
Okay, now I'm going to change this question really
Were you
quickly.
at school the whole time? You didn't even go home?
750 is invested in an account, annual rate 4%. I want you to find, instead of the amount of money, because this is more likely the question that you would have, how long does it take to double? Huh. How long does it take to double?
Just
Figure it
solve
out.
for 150, bro? Or one.
How long does it take for 750 to double at a 4% compounded continuously?
This is what we're doing this.
This was exactly number 3 on your guys' test from the other day.
Wait, but it's
Hold
not.
on. I need to like break this.
Okay.
Wait, 750
What is this?
E,
Mhm.
and then...
Oh no, it's that one.
0.04. So I literally just plug this into my calculator.
Uh-huh.
Wait, this is annual?
Alright, we got
Is it 0.4?
Eddie.
Right.
750 e to point. Oh no.
I wanted it to be in the video. I know it is.
Alright, so then we go to graph and then we use shady stuff. Hey, wait. I'm showing you the brain.
I don't remember.
And then we find the intersect.
Don't what?
No,
You're going way too much. You're doing way too much.
We find the value at one
You have
Wait,
to
wait,
put
wait.
the
Are we
absolute.
doing this problem?
Yeah, that question, how long does it take to double?
Oh, we're doing that one and not that.
Yep, just tell me number of years. Yeah, I crossed off because this is more likely. How long will it take to double? Okay.
17 years.
Can I have my calculator back?
How much did you get?
Yeah, we did it with
17 years?
slow your
That was it.
roll. It's
Wait, why won't it let me look? Why won't it let me?
17 years is correct. 17.328. Did you guys get that?
I got 17. Okay, wait. I divided by
17.328 years is how long it takes to double.
Write the
Miss
approximate
Mitchell,
on the
what if you
calculator.
forgot the equation?
What's that?
What if you forgot the equation?
You can't. You have to remember it.
That's a problem.
Y equals PE to the RT.
There's no space in my doing this.
Or CE to the RT.
I used to be able to remember all this. 0.04. And so you're solving for t,
Yes.
and then you
Does
divide
the 4%, what does that look like when you plug it in as the
0.04.
That's what I read.
Yeah, you guys, when you do a percent, you got to change it to a decimal. 0.04%. Or else you're giving yourself 400% and no bank is going to give you 400%.
Initially, it
I mean, it does.
was 750 e to the power of x times 0.4.
Yep.
Wait, how do we solve for when we're looking for y in here? I was just gonna put in the.
Yeah, no. Do it like this. Watch. I mean, you could, but then you have to change your window and stuff. If I want 750 to double, what's that going to double to?
1,150.
He wrote that too.
I have the equation aloud.
Divide by 50 and 750 and I get 2, which is kind of dumb because if it's doubling, it's always going to be 2, so I don't even really need to
So
take
how do I
that.
plug in like to ask it? That's what I did. Where do I ask for y?
Oh, you put y equals 2. You put y equals that on 1, y equals 2, and then find an answer.
Oh, you just plug in both.
Yeah.
Why is it not?
But look, easier
One half.
because I divided by 750.
Oh, you divide by not.
ln both sides and divide by the 0.04. Now, if you guys are ever doing a half-life question, in like chemistry or something, is that how you do half-life?
Yeah.
We did last.
Guys, it actually doesn't even matter. It does not matter how big the sample is to find half-life, right? Because if I started with,
solely a time measurement.
right, if I started with 500, half of it is 250, right? If I started with 1, half of it is a half. Either way, when I divide it over, I'm getting a half. So it doesn't matter. So half-life questions always go like this. Okay, if it ever asks you for a half-life, yeah, it's 1/2 is e to the rate times time. So it's ln of a half. Okay? And then divided by whatever your rate is. Alright, that's exponential stuff. You guys feel good about exponential stuff?
Yep.
Okay, logarithmic stuff. Here we go. Okay, this is the most important idea right here. Okay, look at how this works, guys. Okay, so for whatever log base it is, now when I'm first getting used to doing this, this is how I convert these back and forth. Log base b, I go b to the y equals x. But you kind of go around in a circle like that.
That's how I remember.
You remember how?
I need to remember how to everything.
Yeah, but I go in a circle. So b to the y equals x. So it's like log base, yeah, that's the base.
Wait.
But the thing I'm taking the log base of turns into the answer, and the answer turns into the exponent.
Wait.
Because they're inverses.
Wait.
Why do we
B
want?
stays. Why did you make an arrow making B go to where Y is?
No. So what I'm saying is you start with b. So you write down like this, b, and then you go to the y equals x. So you just go in that order.
Oh, this isn't.
Yeah, so you just like go in that order.
My
Why do
brain.
we want logs and not?
That's like a
LNs?
terrible demonstration.
We just learn it with logs first, and then we just switch to LNs.
So like, what are logs for? LNs you use all the time, basically because of the relationship with
Any other
logs.
base? Yeah, any other base. Base 10, base 3.
But like, when would we use it? Like,
I mean, not much, but it's defined. So. Okay, guys,
I'm the one paying attention today.
it's crazy. The logarithm is an inverse of e to the x. When I teach how to graph a logarithm, okay? So you got a little bit of space down here. I'm going to graph 3 to the x, and then I want you to graph log base 3 of x. And you guys should be able to do that like no problem, okay? So here's how you do this. When I graph 3 to the x, there's 2 points. What are the 2 points we're always using? 3 to the 0 is 1, 3 to the 1 is 3. 0, 1, 1, 3. That's my graph. Okay? Guys, 3 to the x and log base 3 of x are inverses of each other. What is an inverse?
Multiply it and you get 1.
I mean, kind of, no.
Yeah.
Well, yeah, you're right. No.
It's shaky.
I don't like it. Okay.
I don't like it.
You guys,
Sam like it.
to find an inverse, you take the x and y, you flip the x and y, and you solve for y, right? Okay, so if the point 0, 1 is on the graph of 3 to the x, what point do you think is on this graph?
1, 0.
Yeah. And if the point 1, 3 is on that graph, what's on this graph? So it's 1, 0, 3, 1. And do you guys remember this about inverses? They are mirrored across what?
Wait,
The line y equals x. Okay?
1, 0. That's 4 1s that you did.
So if you can't remember how to graph the log, you graph the exponential and then you flip it.
Ah, so that's how we use the e to the x is the inverse.
See? Now, check this out, guys. Look at these 2 points right here, okay? Look at these points. What is log base 3? We'll look at this one first. What's log base 3 of 3?
You're gonna have to give me a minute.
It's 1. Log base 3 of 3 is 1. What's
Hold on.
log base 3 of 1?
3 to the
If I plug in 1, I get 0, because anything to the 0 is 1.
What?
Okay?
Is there an equation you can use to this, or is it just kind of mental math?
Wait,
knowing
okay,
what-
We're going to look at properties. We're going to look at a bunch of properties.
So wait, it's really, when you ask log base of 1, it's just 3 to the what is 1.
That's right. So when you guys see this, like if I said, hey, log base 3 of 3, what is that? In your head you go, 3 to the what is 3? 3 to the first. And you go, 3 to the what is 1? Well, anything to the 0 is 1. Okay? But it's inverses of your exponential, right? So before you flip the page, I want you guys to go down here, and I want you to graph me your most perfect graph of e to the x and your most perfect graph of ln.
Define most perfect graph.
So perfect, Alan. I want that graph so perfect I can eat off it.
X to the n
That's how perfect I want
factorial,
it.
here we go.
All right?
Now I
Alan, did you get a squiggle?
No thanks.
That was really good.
Wait, what are we doing now? Whoa. Wait, yeah, what are we doing? You're graphing this?
We're graphing our most perfect graph of e to the x and ln x.
Wait, where are we graphing the second?
Landon, want you to go?
You draw your own graph.
Yeah, let's go.
Then it's
I'll have
already
snacks
doomed
next
to
time.
suck.
Are we gonna have snacks every time or just sometimes?
I'm going to try. You told me I have a budget of 500.
For the whole time?
It seems like a lot, but we have 26 sessions.
Oh, for all of them.
Well, like 20 bucks a time. So how do I get 20 bucks worth of snacks for all you guys?
Popcorn.
So I think I'm just gonna like
How about you
buy it and then just.
No, how about you just do snacks on 4:30 to 6:30 sessions? Because
And the Saturday mornings.
no, that's fine though because we have time to get food before and after.
Yeah, well.
So with
I will go
Wednesdays.
and I will get the Board of Education.
But with Wednesdays
added
we
funding
have
to
lunch.
You know what I've
right
noticed?
before.
If you just buy what you buy and turn in your receipts, they don't ask you anyway, so it's fine. All right.
Mitchell, you said that on recording.
Someone watch that. Please, they're not gonna look. All right, what 2 points graph e to the x? What is it gonna be? E to the 0 is 1. E to the 1 is e. 0, 1, 1, e, which is a little less than 3. And it looks like that. That's my most perfect e to the x. Okay?
Now in the x, just flip it.
Now, yeah, the ln of x, because a lot of people are like, we're going to get into this chapter where we're going to take, our next chapter, guys, BC. We're going to take this graph, we're going to rotate it around the axis, we're going to make a solid, and we're going to find the volume of that solid.
That's so cool.
You won't be doing that next week.
That's so cool.
I'm going to take this graph, I'm going to rotate it, and you see it would make like a, almost like a chess piece looking thing, or like a, yeah?
Mitchell, I'm gonna be sick that day.
No?
I'm gonna
Okay.
get sick during that.
So guys,
You're gonna hate life more.
No, I'm gonna pay attention.
if you don't know what the graph looks like, you can't freaking rotate it around an axis, right?
Right.
Okay,
We know
what does ln look like?
It never crosses.
1, 0,
After my name,
E1.
I'm never going to
1, 0, E1, boom.
Wait, what does ln of x do?
Sorry, because you're doing all of the things.
Infinity.
No, like y. What is y
You're doing
of?
all of the things.
It does it, but there's no asymptote there. It keeps going up.
What? I
It
said,
approaches it very slowly.
what are
Then it's not like
yeah.
symmetrical.
Maybe don't.
Yeah, because that one is saying, Isaac, don't make me kick you out of the optional review. The limit as x approaches infinity of ln is infinity, okay? In the same way that the limit as x approaches infinity of e to the x is infinity.
How
They
can
just
it
go to
be
different
truly
infinities.
symmetrical upon the x?
Because one goes there fast and one goes there slow. This approaches 0 here and this approaches 0 here.
Alex on X. You know that.
It's like you're comparing
I'm so
what,
confused.
let's say there's a point over here that's like the point 530 or something. Over here it's going to be 35. They're still going to keep getting bigger.
No,
You know? But you guys got to know what those graphs look like, okay?
Whoa,
So,
wait, I didn't look.
it makes sense now.
flip the page. There they are.
What?
Go
You
back,
guys
go
draw
back,
for
go
nothing.
They're
back.
right here.
1 second. Okay.
Hold on, hold on.
Aubrey, they're on the next page.
Okay, now you can go.
Okay? So, e to the x, I want you all to know how to graph that. 0, 1, 1e. Oh, that's too high. It's like 2 points. And then ln is 1, 0, and
I think
e1.
your graphs are
Okay, guys, listen. When I talk to you about ln, and I tell you there's always 2 ln's that you have to know. You will never leave an answer with ln1 or ln-e. Why? What's the ln of 1? 0. What's the ln of e?
And using
My brain.
Good question. What is the ln of 0?
it doesn't have one.
It doesn't exist.
No.
And you can't take ln of negative numbers either. However, hold on, I got a question for you. What's the limit as x approaches 0 from the right of ln of x? What's that?
Negative
undefined.
Negative infinity. Because as I'm approaching,
Yeah.
which, Dallin, if you're thinking about
Wait, why is it
inverses,
Well, that's
the
why
limit
x-
as x approaches negative infinity e to the x is 0. So that's going to 0 as it approaches negative infinity, that's going to negative infinity as it approaches 0. Yeah? Right? Inverses are super interesting. So as I approach 0 with ln, I use, as I approach 0, it goes to negative infinity. As I approach negative infinity of e, it goes to 0. It's crazy, right? But if you're ever doing limits with e's and ln's and whatever, it's really helpful if you know what those graphs look like. Here's something else that is coming up on, I'm trying to think if AB has this on their test tomorrow, maybe. I don't know. Okay, so look at that. And look at this.
Stop!
Isaac.
Just kind of loud.
Isaac.
Mariah's getting upset at me for it.
I'm upsetting you. Stop. Okay. Guys, In AB, we just learned L'Hopital's rule. You guys remember L'Hopital's rule?
E is a
Yeah,
big
root of top.
I still remember
And you can do L'Hopital's on this, but also you could just compare which one gets bigger faster. As I go to infinity, what gets bigger faster? E to the x or ln of x? E to the x definitely gets there faster, so that goes to infinity.
Anything to an exponent is really
That's the fastest.
Wait,
Now-
L'Hopital's rule, do you do the derivative of L'Hopital's rule?
Yeah, you can do that. No, both.
Okay.
Now, this one, e to the x gets there way faster than ln of x. So what's this one going to go to? 0. So you can look at growth rates, and if you know what the graphs look like, that'll really help.
That's like the most useful
Hey
thing.
Mitchell,
Really
do you
is.
know if they released the master schedule?
He said he's working on it, and it should be out like tomorrow.
Wait,
It says it's out.
the master schedule's been out for like a week?
No, they put it out, but it still make changes.
Oh, they're still making
So
changes?
it's out, but it's not official.
Yeah.
That's weird.
Okay, so here's a bunch of different logs, but you guys can see they all go through this point. Because log base, anything of 1 is 0. And then the other point is like log base 2 of 2 is 1, or log e of e is 1, or log base 10 of 10 is 1. Okay? So those are all different log graphs, but the thing that they have in common is a log graph will always have
Wait,
an asymptote right there.
Physics C.
Okay?
Yeah.
Yes, sir. Always.
What period is that?
All right.
Good question.
We got to do log properties. Do we need a 5-minute break? Isaac, go get the wiggles out. I'm giving you a 5-minute break. Because we're not throwing anything. Go pee, go get the wiggles
You should
out.
answer my question over there during this break.
Okay, which is what?
Pi, like, to the pi root of things like that. Like, what even?
All right.
Apparently that's like a